Okay, sorry about that little pause there. I had a student come to my door, so I had to stop the video and start again. We were just in the process of solving this one right here, but one little thing as we were looking at it to be aware of, this is the square root of x squared plus 1 cubed. The square root of x squared plus 1 is secant, so this is not what we had written there that we were trying to solve. It's just secant squared theta over secant cubed theta d theta, which now simplifies to the integral of 1 over secant theta d theta, which we want to solve, but now 1 over secant is just the definition of cosine theta d theta, which is then, well, the antiderivative of cosine is sine theta plus c. Then I substitute back. Sine theta is opposite over hypotenuse, which is x over the square root of x squared plus 1 plus c. And there's my solution. And one thing I would point out, this looks different, and the other ones we've looked at, this looks different than any of the things we have integrated before. My solution looks different than the solutions I've gotten before, which makes sense because I needed a new trick to get there. So it makes sense that this thing should be more complex, because if it wasn't, then we would have been able to use one of our other tricks to actually solve it. And again, there's this idea that if I somehow solved this all out and got a solution that looked like a simple function that I was used to, like if I solved this all out and my answer was x cubed, well, I already know how to integrate something and get the answer x cubed, which means that trick should have worked on this one. The fact that I need a new trick, trigonometric substitution, to solve this is what kind of tells me my answer also has to look different, like something I haven't seen before. I'm going to make another video going over another trick, but for right now, again, the idea is now we have basic integration, power rule, basic exponentials, basic trig functions. We have U substitution, we have integration by parts, we have trigonometric integrals where trigonometric functions are multiplied together. Now we have trigonometric substitution for integrals like when we have radicals and things inside of the radical that can't be U substituted, maybe trigonometric substitution will work. And then the question becomes, is that all the integrals there are that we want to be able to solve? No, there's actually other things we can't integrate, which means we'll need other tricks. So the next video, we'll go over another trick we have to do.